Hello, everyone. Today, I would like to talk about the critical number in calculus. First of all, we want to see the definition of a critical number. What is the definition of critical number? So let's see, x is equal to c is a critical number of function f if and only if two things happen. First of all, C must be in the domain of F. Or we can say that FC, when you substitute C in here, there, in the function F, does exist. And the second condition have two things. F prime C, derivative of the function at C is equal to 0, or derivative of function at C does not exist. Okay, so let me go back. So this is the definition of critical number. X is C is critical number. Function F is two things happen. First of all, C must be in domain of F, and the second one is either F derivative of the function at C equal to 0, or derivative function of C does not exist. So in order to understand the definition more, I think is good to give the visual, give a graph, visualize the problem. So it will help you to understand more with the graph. So you know that, for example, I take the very simple one, which is the parabola, right? So you can see that parabola, then you know that this vertex right here. So you know that the tangent line, when I draw the tangent line of the parabola at the vertex, the slope of the tangent line is equal to 0. And you know that the slope, this one is c, the slope of the tangent line, which is derivative of function at that point. So f prime c equal to 0 at this point. So in the graph, f prime c equal to 0, that means the slope of the tangent line is 0, which is the tangent line parallel to the x-axis. So that's the first one. So let's see the second one right here. The second one right here, we have, I think, the very easy example that we usually see, which is absolute value of x. Y equal to absolute value of x. So you know that at this point, x equal to 0 right here. So we know that f prime of 0 does not exist, right? Why do we know that? The reason is the derivative of function at 0 on the left is different from derivative of function on the right side. You can see the derivative function on the left is here, right? Is here, which is equal to -1, right? And the derivative of function on the right, which is here, which is equal to 1. So the derivative function on the left is equal to the derivative function at 0 on the right are different. That means the derivative at function at 0 does not exist. So that's why we say it's a critical number. Okay, so you can see many cases that have you heard about the curves? So the graphs look like this, could be like this. This is corner, could be this is quick corner. This is curves. So you can see the tangent line when you draw the tangent line. The tangent line right here is vertical. See that? That means the slope here does not exist. The vertical tangent line doesn't have slope. That means f prime at this c does not exist. So that's why c is a critical number. All right. So typically on the graph will help you to understand more about the critical number, where you can choose the critical number. When you see the graph, where you can see the critical number. So typically now go the problem that they usually ask you to find a critical number, right? That's a find a critical number. The question is how to find a critical number of the function. So typically when you do it, I've seen many people, they will do, okay, they first step, they find the derivative, right? And the second one, they um, they do two things. They let the derivative is equal to 0 and they solve for x. And the second one, they let the derivative does not exist and they try to find x. So that's a critical steps that people used to do. I can give you example in this uh, lecture. I will give example, and I will tell you. Sometimes people make mistake, but not carefully to find the critical number. So the first example is very simple. Like I said, it's parabola, like x squared plus 2x plus 1. Right? That's very simple. And we know that, okay, let's the derivative is equal to 0. That derivative will be 2x plus 2. And derivative is equal to 0. That means we have 2x plus 2 is equal to 0. Then we have 2x is equal to negative 2 and x equal to negative 1. So, boom, this is the critical number of the function. All right, that's typical people would do. And the second example, I would say that fx, I would choose another one. So I would choose gx is equal to x to the 1/3. Right? So we know that g derivative of x will be 1/3 x to the negative 2/3, which is also equal to 1 over 3 x to the 2/3. Right? So then later say we say with g prime derivative equal to 0. Oh, we cannot find any x because derivative 1 over 3 to the x to the third equal to 0. When you cross multiply, you have 1 equal to 0. So there is no x in this case. However, we have the derivative does not exist. That's the case. So you see the derivative is a function. The function does not exist when the denominator is equal to 0. Right? The fraction does not exist when the denominator equals to 0. So 3x to the 2/3 is equal to 0. And when you solve, you have x equal to 0. And then x equal to 0. And then, okay, you say the x is a critical number. Okay, so far so good. And then you can see the graph. I can tell you the graph of, okay. Okay, so we can move on the next page and you can see the graph of, like I said, the graph of y is equal to x to the 1/3. So the graph will be something like this. So this y equal to x to the 1/3. And then you can see the tangent line is, at this x equals to 0, the tangent line is vertical. So that you can see the f prime of 0 does not exist. Okay. Now the third example that I would like to take a look carefully, like x is equal to negative 1/3. Okay, so like we said, we found uh, derivative y prime is equal to negative 1/3 x to the negative 4/3, and is equal to 1 - 1/3 x to the 4/3. Like in the example number 2, we said that, all right, so y prime equal to 0, then there is no such x. Okay, now y prime does not exist, then when x is equal to 0, right, like the previous example. So many people would say that this is critical number. However, okay, so actually it is not a critical number. This is incorrect. The reason I said that, because x here, I agree that derivative does not exist when x equals to 0, but x equals 0 is not, what is the domain of this function? Right? Domain of this function is all value of x such that x different from 0. Right? Because we have fx is equal to 1 over x to the 1/3, so that means x different from 0. So you see x equal to 0 here is not the critical number, because it's not in the domain of f. Let me go back to definition. So we forgot this guy. Many people, when we do it, we forgot it. So that was a trap right there. So be careful. So when you learn the critical number, the definition, we have to make sure that every single line, every sentence they wrote in definition, they worth something. They valid. So we have to be careful. We just do, when they try to find the critical number, people just do this step. Right? So I go back here, find the critical number here. So I would like to add that, I would like to make sure, I want to make sure when you do this way, both ways, make sure that x in the domain of the function. Right? When you do it, you want to make sure S is in domain, x in the domain of the function. I would like to add that when you do find the critical number. Okay, so that's all I would like to mention about today. Um, so good luck, and then if you have any question, let me know, send me email, give me inbox. I will try to answer it. All right, thank you. Next time I will have the tell about the local maximum, local minimum in the calculus. Well, thank you for watching, and see you next time.